So in this example, we're presented with this simple circuit, and we're asked to determine what the value of V1 and V2 are. So that's the voltage at these nodes, V1 and V2. And we notice that they are connected by this voltage source. So if we're going to use nodal analysis, when we have this situation, we have to use what's known as a supernode. And so that's what we're going to do here. So what that means then is we're going to consider everything here in red as just one node. So that's what we're calling a supernode. So this is a supernode. And so with that, considering that as one node, then we just do what we normally do and derive our nodal equation. So we want to look at all the current entering and leaving that supernode. So let's do that. So first we want to look at V1. And so when we look at V1, we look at all the current leaving and entering from that part of the node. And so we have this resistor first. And so with that, then that's just going to be V1 over 6. Again, just using Ohm's law for current. And so next we see that we have this 4 ohm resistor here. And so to characterize that one, that's going to be the difference in the voltages. So that's going to be plus V1 minus, and see this node here is driven by this source. So it's 24 volts, so minus 24. And then that's over the ohms, which is 4 ohms. Now we come over to our next node, which we're going to say is the V2 side of our supernode right here. And so when we do that, we're going to see we have this resistor right here, the 6 ohm. So the current in that one, again, similarly going to be V2 minus 24. And that's over 6, the ohms. And then we see we have a current coming directly into right here. This current right here is coming directly into our supernode. And we're just going to say that as normal, the convention is current leaving the node or the supernode's positive. So in this case, that's entering their supernode. So it will be negative. So then that'll be minus 9. And so that's all the branches that we see going in and out of our supernode. So then we should be able to set this equal to 0. So now we also need to characterize our supernode. So what's going on inside of the supernode? Well, we see that we have this voltage relationship between V1 and V2. So V2 is always going to be V1 minus 12 volts. V1 minus 12 volts. In other words, as we travel from V2 to V1, we hit the negative sign first, so it's going to be 12 volts less than V1. So between these two equations, then, we should be able to solve this. So in this case, we will take this definition of V2 and we will substitute it in to that equation right there, or to that use of V2 right there. And so next we want to multiply through by 12, and we want to rearrange some terms. So if we do that, what we should end up with then is 2V1 plus 3V1 plus 2V1 minus 72 minus 72, and that should be equal to 108. And then again, if we collect all the terms, this should be 7 V1 minus 144. Again, that should be equal to 108. So then 7V1 should be equal to 252, just bringing that over. So when we divide that, both sides by 7, we should come up with V1 is equal to 36 volts. And then we can take that number and put it back into this equation. And when we do, we come up with then that V2 is equal to V1 minus 12. So that's 36 minus 12, and that's equal to 24 volts. So here's our value for V1, and this is our value for V2. So that solves the equation, again, using the supernode approach.